Good evening, everybody. Welcome to the third event of Sheffield Hallam University's Space and Place Group's Perceiving Climate Change series. This evening, we're going to be looking at everything heat related. My name's Luke Bennett. I'm your host for this evening, and you're all very welcome indeed. So just a few opening remarks from me. There will be four main presentations, and in a few moments I will recap on what those presentations are going to be. The event will finish by 9:30. The event is being recorded, the intention being to upload a raw live, not a live recording, a raw recording of the whole thing in 24 hours time or thereafter, probably early next week, actually thinking about it. If, as a participant, in any particular way, you contribute and then have second thoughts about what you've given to posterity, please do get in touch with me in the way stated there by 7 o'clock tomorrow. Beyond that, I'll assume that everybody is happy to be featured if they are featured on the raw recording. Please do raise any comments or questions via the chat function as we go along. Each presentation will have a 5-minute Q&A slot at the end of each presentation before moving on to the next presentation, and then we will have a wrap-up sort of panel-based discussion at the end. So for those of you still joining, please remember to put yourselves onto mute, please. And we will carry on getting underway. So this series is run by the Sheffield Hallam University Space and Place Group, which is a bit of a mouthful. SHU SPG is how I tend to abbreviate it. We've been running our sessions online since COVID, and we've built up quite a nice bank of recorded events now, all available for your delectation via our YouTube channel. And it's to that location that this evening's proceedings will be uploaded in due course. Each year we have a theme. It connects in some shape or other to the wonderful world of space and place inquiry at various scales and dimensions. And this year we have themed our 4 events around perceiving climate change. I'll say a little bit more about what I mean by that in a moment. But I've missed out the opportunity to invite my colleague, John Bridge, to say some co-welcome words on behalf of the Royal Geographical Society. So John, apologies if you're wondering, has he forgotten me completely? I've just remembered you, and now is your time to speak, sir.
Thanks very much, Luke. Yeah, just on behalf of the RGS, Yorkshire and North East Regional Committee, yeah, welcome along to this evening's session. Thanks very much for joining us, and thanks very much to Luke for organising the session, and to all the speakers for what I'm sure are going to be really interesting talks this evening. As Luke's showing on the slide there, we've got a whole season of these perceiving climate talks, which we've been really excited to co-host. Yeah, just the other thing I wanted to say, I'm going to put in the chat just to highlight to any RGS members here this evening that we have our an annual open committee meeting next Tuesday 18th online from 6:30, and it's a chance for any member in the region to come along and find out what we do on the committee. There's quite a lot of changes coming up in the way that the RGS is organised in terms of its regional committees. So come along and find out what's going on. So that's just my little pitch there. Hopefully you can see the link in the chat. I might pop it in the chat again later on as people join and leave. But yeah, that's it from me. Back over to you, Luke. Thanks.
Thanks, John. So yeah, back to this slide. So for the series, for the first 3 events, today is the 3rd event, we went elemental, so ice, then water, today it's heat. And then we went a bit squiffy for November's forthcoming event, whereby we're looking at education. Oh, someone got overexcited then. Would you turn your microphone off for me, please? So the linking theme is perceiving climate change. So I'm thinking through how to connect and look at these issues in a novel way. I thought, well, climate change can feel such a total, but in some senses distant thing, difficult to sort of get your hands on or your senses around. So I thought it'd be nice for us, in the interdisciplinary spirit of these the group's events, to be thinking about how can we, from various different disciplinary perspectives, think about modes of perception and sensing of what is going on, and how it then leads to discussion and or action. So the first session we had looked at ice, and as I've mentioned, the recording is available there for anyone who wants to follow up via the YouTube site. Could someone turn their microphone off, please? Kay? Microphone off, thank you very much. So then we looked at water. Again, not going to go through what you can see on the screen, but that's what we covered back in April. Looking ahead to November, we have our session with 4 presentations themed around education. What are we going to do with these perceptions? How are we going to bolster and interpret these feelings and impressions that we are given as the mode of sensing climate change, and then learning how to do something about it. But for this evening, we are looking at heat as an element within this idea of perceiving climate change, and sticking with the interdisciplinary intentions. We have a mix of scientists, artists, we have an historian. Do we say an historian still, or we now say a historian? I don't know. Anyway, we have Kathy, she can explain, and we have starting us off to contextualize things, Chloe, who's beaming in from Austria. Very grateful to Chloe. Just to explain the ordering of this, because it might seem a little bit odd, the sequencing that we're running with. Chloe's going to give us the scientific-y, climate-y context setting. Really important place to start, can't really not start there. And then we're going to take a step sideways for presentations 2 and 3 to look at 2 aspects of a project, ongoing research project being run at Sheffield Hallam called Just Heat, which involves thinking about living with heat, the way in which, you know, we're not seeking to escape from the world of heat in terms of climate action, but we're seeking to live in a world that is in the right part of the Goldilocks spectrum, if you like, vis-a-vis heat. And I think you'll find our 2 middle presentations an interesting sort of counterpoint to perhaps the more obvious direction of taking this into the question of how do we understand and respond to extreme heat. They're looking at almost sort of domestic necessity of heat and how we go through various energy transitions, having regard to our affective connection to warmth and heat. So I think actually when we get to the end, you'll see the way in which the concoction blends together in I think an interestingly holistic manner. But I would say that because it's my running order anyway. Right, so that's enough from me. So I'm going to stop sharing my screen by pressing the correct button, which that wasn't. Right, so I'm stopping the screen and I'm inviting, each speaker will introduce themselves. They know that we're running it in that fashion. So I'm going to invite Chloe, please, to load up and present away, if you wouldn't mind.
Thank you, Chloe. Great. Thanks, Luke. I'm just going to share my slides with everybody. Can you see that okay?
Yeah, that's looking great. Thank you.
Okay, great. So hi, everybody. Thank you for coming along to this talk this evening, and all of the presentations. Everything looks really interesting. So this evening I will be talking to you, Are Heat Waves Just a Long Hot Summer? Raising the Understanding of Extreme Heat Risk. and I'm Dr. Chloe Brimicombe. I'm a postdoctoral researcher at the University of Graz, which is about 2.5 hours away from Vienna in Austria. But as you might be able to tell from my accent, I am from the UK originally, and I finished my PhD and got it last year from the University of Reading, and I'm from Reading originally. And I research everything to do with heat waves. That's basically most of what I do. So it's great to be able to share this with you. So let's move this. So what's my motivation for doing this and the motivation for researching heat in general? So we know that some people are more vulnerable to the effects of heat than others, and these are pregnant women and children, the elderly. In this definition, that's those over the age of 65, and outdoor workers and those with pre-existing medical conditions. And as we'll see, this is because they have a limit in their ability to physiologically, so your body responds when you're affected by heat waves, and they have this limit in their ability to regulate their temperature internally when they are exposed to high periods of heat and high temperatures. And so this means that they're more at risk of overheating and experiencing heat-related illnesses. And as I believe in the UK might have been in the media recently, also can result, sadly, in the loss of life at the most extreme if there isn't access to cooling. So basically perceptions of heat. So unlike other hazards, or as Luke was showing, ice, the main way that we perceive heat is through feeling or sense. So this is quite different from when you see something coming towards you. However, your body response is quite similar, as if you were to see something. So everything has what we call a thermal comfort zone. So this is a range of temperatures, a range of thermal environments where we feel comfortable. We're not exerting energy from the body to keep ourselves either warm or cold. And this is other things other than just temperature. This includes the impact of the sun and the incidence of solar radiation on our body heating us up. It also includes factors like relative humidity, which affects how we lose heat from the skin surface, and also wind speed, again, affecting our heat transfer of the body. Other things that can affect this is also what you're wearing, whether you're used to the climate you live in, and how much work you're doing. Another reason why outdoor workers would be more at risk. And then what we know is that if you look at the diagram on the right here, these are sort of the limits within the core body temperature. So internally, where you would experience different types of responses to different temperatures. So right down at the bottom there, you have hypothermia, and then you would lose consciousness and then unfortunately die. And then at the top of the spectrum, you have hypothermia, which is death from heat stroke. And there's a lot of other heat-related illnesses. And so what you also have is heat stress, which is a buildup of body heat, either as a result of exertion and or the external environment. And this is quite different from heat waves. So a meteorological term for a period of above average temperatures of 3 or more days, which is a guideline definition by the World Meteorological Organization, are known as heat waves. So over the UK and Europe, this is caused by basically a big area of high pressure. You might have heard of like the Azores High building across the UK, or like, you know, like you see pictures of the beach and Ibiza weather sort of in the UK. This is because a high pressure system up in the atmosphere moves across and brings warmer air and then stays there, and this causes basically a heat wave. And that's the main cause of heat waves in Europe and the UK. So the definition for heat waves in the UK is a period of 3 or more days and the 2 intervening nights of above average temperatures for the last 30 years. And this depends on the region of the UK you're in. And then we have a different threshold for heat health warning system. So we have 2 warning systems in the UK. This is one for heat waves, where you'll see an amber or red alert, or there's a heat health early warning system, which targets the vulnerable groups that we saw at the beginning. And this gets disseminated kind of differently. And so you'll see the response quite differently, with heat health going to those that need it most, whereas heat waves go to the general population. So heatwave reporting, unfortunately, with what happens is that although in recent years you will have seen an increase in number of heat waves being reported, because sadly we're seeing a rise in number of heat waves with climate change. So they're growing in intensity, so how hot it gets, the area they cover, how long they last for, and how often they occur. But what we see in international reports that track these sort of events in countries is that heat waves are less often reported in these official figures than other hazards. And there's also this effect in the news media often, where you would see maybe flooding or visual hazards being portrayed more often in heat waves, because it's quite difficult to visualize a heat wave, and we often see this done in a way that can be problematic to understanding the risk. So what we know is that more research is needed on response to early warnings and reporting of heat waves in reference to a cultural context. So in the UK, as we'll see, there's quite a different response to a heat wave than if you were somebody living in rural Africa. So if you were in, for example, the West Sahel, so this is countries like Ghana, and you were running a family farm, your response to a heat wave and the messaging you would need is quite different to somebody who's living in the city of London. So it's very important that this is taken into account when we're reporting heat waves. And then what we also see is that sometimes if we engage people, which I guess is what Luke was thinking with this series, if we can engage people with extreme weather and also the visuals of climate change, we can improve that understanding of it. And this is really important because we want to protect the lives of people that are most vulnerable to heat waves. And we know that if we give messages to the social network of people around those vulnerable groups, they're more likely to take action and adaptive steps. So, for example, if you had a grandma and you were to ask them to drink water, they're more likely to do it if you ask them to than if they saw, say, me or another scientist on the news saying to drink more water, because they hopefully trust you more. So that's something that is hopefully getting across through heatwave messaging. But as I was saying, unfortunately, a lot of the images we see in the media at the moment, it's got slightly better since the July 2022 heatwave in the UK, when we broke the record of 40 degrees Celsius in July. But most of the images we see in the media are ones like this. So you'll have pictures of lots of people at the beach or people in pedalos. There is an incredible range of people using fans in the media. You would be surprised at the diversity of people that now use fans that are being taken picture of. And then, of course, the classic that you always get when there's a heat wave in the UK is the reference to the 1976 heat wave and drought. And this is a question that everybody gets quite a lot around the time of a heat wave in the UK. And it's kind of unhelpful because we know that heat waves have got a lot more intense and are occurring a lot more frequency since that one in 1976. And also the patterns that cause them in the atmosphere can be quite different. And so 1976 was quite isolated to the UK, whereas now we see quite a lot of our heat waves also affecting neighbouring countries in Europe, whereas this one was very much quite localised to the UK. If you look at weather maps, it's quite interesting. And so basically what we need is the change from these sort of images to ones that tell the story of those that are at risk. And as you saw on my first slide, those images do actually exist. It's quite difficult though, because these newspapers use the same stock images. So there's a couple of different organizations that take images for newspapers. And so those are the only ones that are available. And that's why you see repetitive use of the same lady with a fan in several newspapers. Or you would see the same picture of perhaps Bournemouth Beach. Because they have like several agencies that are taking pictures all at the same time. So what is occurring from colleagues and others is talking to media companies, and then trying to encourage people to go and talk to local communities about the effect of heat on them, and taking pictures with local communities, so that we can have more representative pictures in the media of the risk of heat wave, so that this basically better educates everyone and can do protective messaging, which is really important. So then the other response that we see in the media in comparison to Fun in the Sun is we also see fatalism in heat. So sometimes people have a very low adaptive capacity and what we call high social vulnerability. So this is where they have different socioeconomic factors that make them more highly vulnerable to heat. So although we have the vulnerable groups, we also have this aspect of socio-demographics that also raise the risk of someone to heat. So this can be factors like where you live, how much you earn, what sort of job you're doing, what age you are as well. Even though at risk group, you can also have, for example, if you're a certain age and you're pregnant, you might be more at risk than someone who's slightly younger than you. It can also be to do with ethnicity, whether you've immigrated to a country. Sort of factors like this can, in some cases, mean that you're more socially vulnerable to a heat wave. And then adaptive capacity and limiting the ability would be whether you own a house and would be able to fit shutters on the outside of your windows to shade your house from heat, whether you would be able to maybe, if you were really, really vulnerable, install some sort of carbon sensitive air conditioning, that sort of thing, because people that are in rental accommodation clearly can't do that, and that has a lot of different problems. And then also adaptive capacity for children might be that they need to ask their parents like what clothes to wear or ask for a drink, and so this limits their adaptive capacity to heat, or basically in the case of maybe even like if you see cases where you shouldn't leave a dog in a car, like the animals as well have limited adaptive capacity, pets, those sort of things. So really need to take that into account during heat waves. So then one way, as I was saying, that we can adapt to heat waves is through early warning systems. So basically, there's some UN agencies that do global monitoring of hazards, and they came out with this report, which was led by the World Meteorological Organization, called Early Warnings for All. And basically, what they want to do is make sure that there's global coverage of heat waves, floods, droughts, and storms by 2027. And basically how they do this is through an integrated approach to early warning systems. And we consider this a climate service. So this is where you basically have lots of different aspects covered by companies, or in this case, an early warning system, which brings together important aspects and sectors and gives them tools so that they can adapt effectively, in this case, to heat. So this covers 4 aspects: risk knowledge, monitoring and warning service, dissemination and communication, and response capability. And so I've mostly been focusing on dissemination and communication in this talk, but all of the other ones are very much relevant to heat waves. And we see a lot of barriers occurring for all of them. This is somewhat being overcome in the UK in recent years because of the work of the UK Health Security Agency and the Met Office, who jointly issue the warnings for heat waves in the UK. They also write reports every year to monitor the effects of heat on mortality and hospitalizations, and then they make adaptations based upon this every year to update this so that they can put in place the most up-to-date research into their early warning system to keep as many people effectively safe as possible. So that's basically the process for the UK, and this is mirrored in different countries as well. So yes, so mostly talking about dissemination and communication. So there's three main ways that we can overcome the barriers of communication and dissemination in early warning systems. And these are co-creating messages with effective communities. So I'm part of a project called High Horizons, which looks at the heat impacts on pregnant women, children, infants and newborns, and healthcare workers in different parts of the European Union and Africa. And one of the aspects of the project is that colleagues of mine have gone to different communities in South Africa and Zimbabwe, and also in Sweden, and they have co-created messages with the effective communities of the impact of heat, so that they can put this in an individualized app, which is a type of early warning system, so that they can give them the information they need during a heat wave to keep themselves cool and limit their impacts. Because for pregnant women, the impact of heat can be a rise in different health conditions like preeclampsia, but it can also lead to preterm birth in some cases. And also it may, in sort of a more African context, although it could also be the case in Europe, lead to lower birth weight babies, which can have ongoing developmental issues for children. So it's really important to keep them cool, basically. And then giving adaptation advice as well as a warning. So there was a study for Germany where they issued warnings at an event during a heat wave. And what they found was that if they gave an adaptation advice, so like drink more water or stay inside during the heat of the day if your building is cooler, then people were more likely to take on board this advice and be prepared than if they just said, be careful, it's hot outside, because they knew what to do and they had a way to effectively stay cool. And then finally, it's really important that we don't just use facts and figures. So recently, you will have seen for the last 12 months that we have had, I think it's about 1.5 degrees Celsius of above average warming. So this is where the average temperature is 1.5 degrees above pre-industrial levels in comparison to pre-industrial means about like the 1800s. I think it can be slightly different, but I think it's 1890s. And so this has been like the hottest 12 months on record, but that's quite abstract. And so if we use imagery and storytelling, like for example, you have a woman and she's pregnant and she has to walk in the heat of the day to collect water for her children and her family. But this has caused her to have to give birth early, and therefore the baby needs extra care because it's been born too soon. So that sort of image, and that's as effect of climate change, that's much more tangible than 1.5 degrees Celsius. And so using these images and real communities that are affected by climate change and storytelling could be a really powerful way to disseminate the risk of climate change and make it more relatable to us all, alongside the important facts and figures that are coming out. So anyway, that's the end of my talk. Thank you very much for listening, and I'd be very happy to take any questions. If you'd like to get in touch with me, I have LinkedIn, I have X and Twitter, and you can also email me at any point. And if you'd like to check out the project that I'm on, this is the link to the website. You'd be more than welcome to check it out. There's quite there's quite a lot on the website, and just feel free to get in touch with us. Thank you very much.
Thank you, Chloe. That's wonderful. That set us up really nicely for this evening's proceedings. When I spotted your work online, I thought it was a wonderful blend of hard science and the cultural dimension too, and I was quite impressed at the number of disciplines that you seem to be able to straddle together in the work that you've done through your doctorate and beyond. So thank you very much for joining us this afternoon. And also picking up on the perceiving dimension. I've just lost the chat box, so I better just get it back up. But I got a question for you whilst I'm doing that. During the COVID pandemic, the media got quite heavily involved on a day-to-day basis at first in risk communication. And I'm wondering whether post-COVID, there's been a sort of an improvement in the way in which risk communication is done by the media, or whether in fact there's been a retreat backwards now that people are saying, oh, well, now people are saying whatever they're saying. Did COVID change things? And if so, was it towards more risk communication and more effective risk communication, or was it, or have we now seen a sort of, oh, mustn't nanny people kind of counter reaction?
That's a very good question. So what we saw during the COVID pandemic was actually a massive underreporting of heat waves and flooding and all sorts of climate change that was occurring at the same time as the pandemic. And definitely at some points of the pandemic, it did feel quite heavy, but it was a heavy period of time, right? So we have seen an increase in sort of understanding of risk by the media, I guess, since the COVID pandemic, but it would be difficult to say whether that is a result of the pandemic or because we've seen more intense heat waves and other flooding events in the UK. So I mostly focus on heat waves. So in terms of heat waves, there was definitely an improvement for the 40-degree heat wave in the UK, and then also the heat wave that followed that. The problem with the heat wave that followed was there was quite a lot of confusion because it also coincided with a drought, and that's something that actually needs to be improved upon further, because it's very difficult to tell someone to drink water when you're also telling them they're in drought conditions. So it's quite like confusing. So compound hazards is another issue in an area, but yeah, it's an interesting point. I always thought it was because of the intense heat wave, but it could definitely be as well as because of the COVID pandemic changing the way that they sort of understood risk. Yeah.
Thank you. There's a question come in the chat. What is the biggest impact that the High Horizon project has had on communities so far?
So far we've run national indicator workshops with ministries and also some key community groups, so non-governmental organizations in South Africa and Zimbabwe, and that was in January this year. And that's really supported in-country processes to monitor the effects of heat on maternal, children and newborn health. Another aspect of the project that they've looked at the moment is health care workers' health and well-being inside facilities. And in the upcoming year, they should be putting in place adaptation measures to limit the effects of heat in selected health care facilities. There's also carbon emission monitoring from the project, which is slightly left field from the heat, but this has been really good. They're developing a tool so that healthcare professionals can know the best way to limit the carbon emissions from their facilities if they have a limited budget, basically. So there's quite a lot of good work on the project. So we're hoping to have quite a lot of impact, and it's exciting to work on, actually.
Thank you. I'm going to stitch together some of the comments that are sort of in the chat, because I think I can blend them together into a question. My perception is that in Australia, there's a lot of sort of common understanding of the link between sun exposure to sunlight and UV and skin cancer. much less so in terms of skin protection here in the UK, and the comments that I'm linking to in the chat are about people who've had skin cancer from sun exposure. And I think the point they're making in that discussion in the chat is that these individual stories understood retrospectively by the person who suddenly realizes, oh, I've suffered this because of or despite my protections, are individual experiences, and they don't necessarily knit into UK sun culture, if I can call it that. And I just wondered whether you stop talking so that I always come back. So sorry, the question is, can we learn from Australia? Are we learning from Australia? How do you transfer awareness, sunshine awareness, from one place into somewhere like the UK?
Yeah, so it's kind of a separate issue. So it's you can get cancer as a result of sun exposure outside of heat waves. So it can be affected. So you can see higher incidence of it, but the link is you could experience sunburn even on a cold day, right? So, but to answer the question, so I don't really know that much about, I have to say, about sun cancer in Australia. But what I do know is that in Wales, a couple of years back, they kept putting flags of lobsters everywhere as part of a scheme to try and improve the awareness of Welsh people to needing to wear sun cream because of high incidence of sunburn and then sun cancer. So I think there is some schemes by health authorities in the UK, but it's probably the same as heat. In terms of the understanding is quite poor of the need to wear sun cream, and maybe there is something that could be done around the messaging to improve that wearing of sun cream during a heat wave. Is also interesting because there's actually an under research on the effects of sun cream on how we then lose heat. And so the sun cream manufacturers say that there isn't any effect, but there's not many other studies suggesting kind of why, because you would assume that if you put something on your skin, that would be a barrier to you being able to lose heat, but apparently not so far. So that's quite good news.
Okay, thank you very much, Chloe. We're going to move on now to Kathy. There we are.
Hello, everyone. Just double check, yeah, I'm not on mute because that's a classic. Hi, everybody. I'm Dr. Kathy Davies. I'm a postdoctoral researcher and historian on the Just Heat project. Today I'm going to be presenting at Sheffield Hallam University, sorry. Today I'm going to be presenting from devouring monster to instant wraparound warmth, understanding our home heating past to inform a low carbon future. And just to start this presentation, actually, I'm going to let the principal investigator, Professor Amy Ambrose, tell you a little bit more about it. So,
Kathy, just before you do that,
yeah,
you might not be able to clear this, but I think your button bar is on the same screen as your presentation. If you try and drag that out of the way, at the moment it's showing as a sort of black image.
Oh, right, okay.
You might not be able to move it, but just on the off chance that you can move it, I thought I'd just mention it.
No, but I'll keep it in this corner because I can move it, but I can't get it off, if that makes sense. So okay, I'll just keep it in that corner and it shouldn't obscure anything too much. Is that all right?
Thank you.
Okay.
The way we heat our homes has changed fast over the last 70 years, moving from wood and coal to gas or electric heating. These changes have had a profound impact on the way we live our lives. This is because home heating influences the design of our homes, the way we work and learn, our health, our family life, and the infrastructure we see around us in towns and cities. Access to new forms of heating isn't always even, and it can have profound impacts on social and economic inequality. As the transition to low carbon heating gets underway, it's crucial that we find ways to make that process fair for everyone. Just Heat is an international research project spanning the UK, Romania, Sweden and Finland that investigates historical heating transitions. The project brings together energy studies, fine art, history, architecture and political science, working together to gain a detailed understanding of how home heating shapes our lives. It particularly focuses on understanding the fairness of past heating transitions so that we can help ensure a more just transition this time around. To find out more about the project, please go to our webpage.
Thank you, Amy. So as Amy said there, Just Heat is an interdisciplinary project, pan-European, and it focuses on the social and cultural history of home heating with the intention of better understanding current transition and informing energy policy. So I'm the historian on Just Heat, and it has been my job over the course of the project so far to look at archive sources and collect oral histories to understand this history of transition in Britain. And we focused on living memory, with oral history being the crux of the project in terms of research method. So as part of this presentation, I'm just going to give you a whistle-stop tour of some of the key developments that have happened in terms of home heating in Britain, basically from the 18th century to the present day. And then I'm going to focus on the oral history collection, with particularly on the first case study in the collection, which is Rotherham. And then to conclude then, I'm going to let you know a bit more about how we're trying to inform energy policy in current transition. So this image here is a Victorian range, or described by Lawrence Wright in his 1964 History of Heating as the devouring monster. Devouring because it was so inefficient in terms of fuel and labour. But this was the kind of technology that dominated British homes from the late 18th century through to the 1960s. But since the end of the Second World War, there has been seismic change in Britain in terms of home heating. And despite the fact that in 1945, the open hearth and the Victorian coal-fired range, like pictured here, were the dominant technologies in British homes, with 95% of households in Britain using coal, coke or anthracite for heating, and only 5% of households using gas. Over the course of the late 20th century, we see a huge transition to gas central heating. And by the 1990s, over 90% of people were on gas central heating in the UK. That stands at around 74% today. So some of this transitions historically, first of all, the transition to smokeless fuel. So while most people were burning coal in Britain after the Second World War, and before that, of course, the first major transition was to smokeless fuels. And campaigns around smoke abatement had existed since the 19th century, but these didn't really gain traction in terms of the domestic hearth until after the First World War, when it became a public health issue around how smoke and the contribution of domestic chimneys was impacting public health. But it wasn't until actually after the Second World War and in the 1950s, after the Great Smog in London, where thousands of people died in just a space of a few short days, that government policy was finally introduced to address smoke issues in the UK. And the Clean Air Act 1956 ultimately gave authority to establish smokeless zones in areas in the UK that had particularly high concentrations of smoke. So this essentially caused a transition, early transition to some non-solid fuel systems such as gas and electricity, but mainly a transition to smokeless fuels such as coke and anthracite. Now, it wasn't a smooth transition, and this is something we've learned throughout this project so far, is transitions aren't linear and they don't necessarily happen how policymakers might have imagined or liked. And some resistance to the smokeless, the Clean Air Act came from mining communities who received concessionary coal as part of their wages. And ultimately, there was no economic, cultural or political initiative for them to transition to smokeless fuel and away from house coal. The second big transition and the most significant transition in home heating and indeed in British energy history is the transition to high-speed gas. Called high-speed gas by Sir Kenneth Hutchinson, who was the head of the Gas Council in the 1960s. essentially the gas infrastructure had existed since the early 19th century, but from the 1960s onwards, there was a move towards gas, particularly gas central heating. So this was propelled by the discovery of North Sea gas in 1965, and then the natural gas conversion programme, which involved converting 40 million appliances across 14 million mostly residential customers. So Dennis Rook, the chairman of British Gas from 1976 to 1989, described this as perhaps the greatest peacetime operation in the nation's history. So the cost, the logistics of this massive transition to this new fuel source, essentially, was enormous and actually happened quite quickly. Other developments include energy crisis in the 1970s and the measures taken to address that. This is where you see fuel poverty emerge as a real issue in the UK. From the 1980s onwards, although sort of managed decline preceded this, you see the end of King Coal, the King Coal era coming to an end, and this transition away from coal is ultimately completed by the 1990s. And then in the 1990s, there is a turn towards more environmentally conscious policy with regard to home heating. But still today, as I've said, 74% of households in England use mains gas central heating. But how do people remember this time? And what does that mean? How do people relate to heat? And then what are their memories of heating? And what can we learn from that? So Just Heat has been collecting oral histories. Across the whole project, there's been 100 oral histories collected so far across the 4 countries. And these ultimately capture the personal memories of keeping warm and feeling the cold at home over people's lives so far. They provide oral testimony of the everyday lived experience of home heating in Britain and give voice ultimately to people who might not normally be asked about their experiences. And this has been a contribution to the historical record as well as data for the analysis on this project. So some of the main findings for us so far have been that this coal fire was central to the home, to everyday life. It was the primary source of heating in working class homes. There was usually only one fire. And it wasn't just about heat. It was the social centre of the home where families gathered on an evening, where they got dressed on a morning because bedrooms were cold. It was where laundry was dried. People even cooked on their fires, especially if they had a range. And it shaped the use of domestic space. Ultimately, the living room was the place where people lived in. People didn't use their bedrooms, apart from to sleep. This was also impacted by daily, weekly and annual routines. So, for example, Christmas emerges in people's memories of heating as a particularly warm time. And it also influenced family life. So people have quite a lot of emotional connection to the fireplace, remembering who was sat there, who they spent time with. And I'm just going to play this little clip here of Sue describing the Yorkshire range or the devouring monster.
Yeah, it was a big fireplace. Ours was black, some of them were cream, and so you had your little fire, and then there was an oven at the side of it, and then on the top you could put, keep things warm, and on the fire Mum had especially used to boil the kettle, there was a little hook and you hung the kettle on, and that's how she boiled the water. That's
about that.
So some of the quotes we've had from the oral histories is around the coal fire being crucial to the household, the hub of it all, the hub of the house, central point of the home, the centre of the universe. Everything happened around the fire. And ultimately, the fireplace was fundamental to the household economy and played a crucial role in that in terms of fuel and labour. Fuel was precious to working class people, in particular because of the cost. And there were various coping mechanisms from people at times of sort of desperation or hardship, such as burning furniture when they didn't have access to coal. The labour of the coal fire as well was particularly gendered. Women tended to make up the fire and maintain it throughout the day unless they were working. And as well, in the post-war period, as more women were going to work and leaving the home, daily routines shaped how the fire was used again. So it might not be that it was burning all day where previously it would have been. And in mining households, and Rotherham, like I say, was the first case study for the oral history collection for Just Heat. In mining household, this labour extended obviously beyond the household itself to the working environment itself. But the expenses of coal was slightly different for mining households because they received concessionary coal. And concessionary coal was ultimately part of the miners' wages, and people described how spare load from miners would be bought from these families. Everybody did it. It was how it worked. But communities will also share fuel, and there's instances of people giving this fuel away in mining communities, especially where there were children involved. And one miner's widow used to drop coal over the side of a fence to a single mother and tell her, you make sure them babies are warm all the time. But other people talk about grandparents who were miners having really warm homes, whereas their own household, where their parents were steel workers or retail workers, that being particularly cold. So that contrast came through quite clearly. The importance of union action also came through, and the extension of the concessionary fuel scheme, with Richard describing the extension of concessionary fuel as an enormous benefit to his family.
Well, Kevin was a...
So obviously for this case study, Rotherham, as I've said, it's really important to the local economy, and that connection between the home and the local economy, fuel and heat, has been a really interesting dynamic of this specific case study. And it really demonstrates the place-based nature of how people experience warmth at home. And Graham, actually, one of the other participants, he grew up in Huddersfield, and he actually placed much more emphasis on wool for warmth than on coal in comparison to those who've grown up in Rotherham. So as Huddersfield was a wool town, he remembers much more about knitting and the importance of clothing in comparison to the fuel itself. What's been really fascinating about these oral histories is obviously the dynamic of the people who are talking, predominantly over 70, remembering their experiences as children. And these childhood memories often contrast between work and play, where children were often involved with collecting fuel, helping to light fires, although being warned of the dangers of it, fetching the coal in when it was delivered outside. And I'll just play Christine.
Yeah, they used to deliver it at gate, drop it at gate, and then you had to go and get it in and throw it in coal house and then build up woods up so it didn't fall out. Yeah, so nearly everybody down here worked at pit. So they all got the coal dumped at gates. So you used to go and help get theirs in, because there were a lot of old people. So I used to go and help get theirs in, as well as my dad's. So, yeah.
And what's quite interesting, actually, is these childhood experiences really shaped how then people relate to heat as an adult. So, for example, Carol, she was not born in the UK. She was from Singapore. She emigrated to the UK when she was 17, and so she'd never seen a fire in this context. And neighbours had to come around and help her and show her how to light a fire within the British context. And that kind of early cultural heritage was missing for Carol, and she always described how that affected her throughout then her life, because she always struggled to light the fire, she didn't get it, and she always felt the cold. And this then passed on to her daughter Liz as well. And that came through quite clearly, like the kind of absence of a shared knowledge and the impact that had. But it wasn't just about work, it was also about play, and there's memories of playing games, the piano, reading, people lighting sparklers on the fire, much to their parents' annoyance, burning broken model aeroplanes, cooking crumpets or pikelets on the fire. All of these sorts of things were really emotive and deeply personal stories around what heat and heating meant to these people. But one of the biggest themes is the sense of emotional comfort and care, how the provision of warmth was more than just a physical need. It was really about supporting the emotion and social life of the home and feeling a sense of parental care or familial care. At times of illness, people remembered being kept extra warm. People had guilt around the sacrifice of their parents that they remembered quite explicitly. And I'm just going to play Trevor here talking about that himself.
And I regret, but when I was a teenager, I regret hearing my mother come home and I'm still in bed and she makes a fire and then I get up when it's warm, and I regretted that.
So the comfort of children came through as a really important aspect of the provision of warmth. But of course, this was not always possible due to financial constraints and also just the domestic makeup of the family, depending on individual circumstance. But some more quotes here. The fire in the kitchen had a space above the oven where Mum put our gloves to warm them. One Christmas, we got a hot water bottle each. My sister got a Red Riding Hood one. Mine was a dog. We loved our little hot water bottles. And it's a nice feeling, isn't it? Looking into flames, you sort of drift off, staring, watching the flames moving, a bit like meditation, and you've got comfort of the warmth. And as well as these human experiences, there's also been a really interesting findings around how between heat and animals within the home. And people talked about their pets. Rita mentioned how her Doberman would bark at the Calagas heater, which is spelled wrong there, Calagas heater until they would switch it on. And Dinah cleared a cupboard next to the Yorkshire range to put her dog bed in. And Graham remembers caring for caged lambs from the local farm and putting them in the oven shelf, not on a Sunday and not with the Yorkshire pudding, just to point out, but to keep them warm when they were basically orphaned lambs. And in terms of remembering transition itself, the oral histories demonstrate the fragmented nature of transition. There's this idea of this mass transition to high-speed gas, but ultimately people got plug-in devices, they got a gas fire before gas central heating, they relied on a mismatch of different kind of systems. And also it wasn't sort of in this time, you know, North Sea gas is discovered and there's a big push for the transition and everyone switched at the same time. Thinking about Christine in Maltby, her family didn't switch to gas until 1999, and that was because her father died, who was a miner who used to get this concessionary coal. And so once that was removed, that was then the motivation for them to switch to gas. It made sense after that, it didn't before that. But people do remember the higher levels of thermal comfort that came from the transition to gas, but that emotional care and that social and again cultural aspect is missing from the stories, and there's something to be learned from that in terms of the messaging for current transition. Ultimately, it was linked to this idea of modernity as well in post-war Britain, that the future is coming, and the messaging around the transition to gas and how people remember it still was very much connected to that as an exciting prospect rather than something being forced upon them. So in Rotherham today, 84%, so 10% more than the national average, are still on gas central heating, which is quite interesting considering it was a coal mining community. So even though it was slow to transition, it's now actually got more people on gas than average. And Carol from Maltby, she says, it was only after gas central heating came in that I finally felt warm. This is the lady who grew up in Singapore. I remember thinking, thank God for that. I could flick a switch and the heating would come on. It was a different kind of world. You can't beat it. Showering is beautiful too. I was a lot happier after central heating came in. I had less anxiety. I do not touch the heating now, and that works very well for me. They're not going to take my gas heating away, are they? And so one really interesting thing about the Just Heat project is thinking about this connection between past, present and future. And whilst we've been talking about history here in this presentation, ultimately, that's still very much some people's present. The coal fire is still very much some people's present. So how do we consider that in terms of current transition and the future, when for many might think they're still living in the past? I'm just going to play you this clip here from Mary. She lives on a tenant farm and still heats her home by a single coal fire today. So this was captured in 2023.
I get up at 5 o'clock every morning. I come down here.
Oh.
I put the kettle on and I try and get it all cleaned out for by the time the kettle has boiled. I've got it off to such a fine art. Right, so I get a long-handled brush, I put a mask on, and I get a long handled brush because I can't bend down like I used to do, and I sweep the ash into the back of the fire. Then I get that old poker there, this black thing, and I scrape it out. And then I lift off the front of the fire, pull out the ash pan. Often the ash is hot, so outside I have a big round metal container, and I tip the ash in there so I don't have to put it in the bin. And then I come back in, shove the ash pan back in, and put the fire door, clean it down.
So that's Mary's morning routine in 2023, and this is actually a picture of her fireplace, which is still there today. And when house coal was banned across the board in February 2023, Mary said, "My eyes were watering when the coalman last came. He said, 'I'm sorry, it's only going to be smokeless coal from now on. We used to have a bag of house coal to get the fire to ignite. This is the first time we've had this said to us. We've always been able to get fuel.'" So ultimately, this, just to conclude the kind of the contribution of this oral history collection, it reveals the deeply personal connection between households, families, heat and fuel. It illuminates the social and cultural dimensions of home heating and the impact of change on everyday life. It demonstrates the importance of place in shaping attitudes to heat and keeping warm at home. And as I say, this is particularly obvious in Rotherham. Our second case study, Stamford, we're analysing at the moment. And this gives voice to the home heating experiences of ordinary people. It also connects the past with the present. And as I say, that interplay between past, present and future is really important to consider. What is the starting point here? You know, what is the present? Mary's situation is akin to still, 60, 70 years ago. And thinking about past and present, I really enjoy this picture here in front of the coal fire with this gorgeous tiled surround. This picture was actually from a participant in Stamford rather than Rotherham, of Christmas Day with the family, the children in front of the fire. And in the present day, the tiled surround here is still there, but the technology's changed. But ultimately, this is his mum's house still now. So that's the sort of a whistle-stop tour of the history and the oral history and those personal experiences and some of the things we're finding out here. But how are we then informing energy policy? So Just Heat, a core part of this is engaging with cooperation partners throughout, from the beginning of the project, from the design of the project, through to the entire project throughout. So this includes national and local organisations, including local government, national government, but also voluntary organisations who are interested in energy poverty and things like that. So engaging with these cooperation partners throughout. Also, we're planning and delivering public conversations, a series of workshops essentially where policymakers, oral history participants and other volunteers from the public will come together to discuss past, present and future heating and think about some of our findings from the project and what that means to them. And so we can create this space where these voices can be heard and policymakers have the opportunity to directly listen. This is also contributing to academic and policy debates, and there are some interim messages that have come out of the project so far, and we have a report on the project website that outlines these, but I do believe I'm running out of time now, or already have. So these interim messages, please do have a Google of Just Heat project, or scan this QR code now, and you'll go to the project website. And there you'll be able to find the interim report, which talks in much more detail about the kind of messaging for policymakers that can be taken from this history. Thank you very much.
Thank you, Kathy. That was great. Really rich insight into sort of lived experiences, as you termed it, of not just heat but also fuel. Now, I have a question that I don't want to sound judgmental of communities that you are dealing with, but I think it's important to sort of draw out in a polite way, at least. The cultural politics of coal and coal communities have been very distinctive over all the decades that I've been alive, and prior to that. You know, coal has been a sort of national emblem of working class achievement and community stability and solidity and what have you. But more recent decades, I suppose, have seen a counter or a parallel discourse emerge, which is, you know, evil fossil fuels and the emissions from them contributing towards atmospheric loadings, etc., and a sort of a legacy born of that. And it just strikes me that you've got two separate discourses at work here, one of which is sort of rooted in a pride and nostalgia, and one of which is increasingly judgmental. And I wonder, in terms of your field work, was there, for example, a defensiveness about that coal hewing, and do these communities connect to the atmospheric emissions, or are they, and if so, are they defensive about it, or what's the interplay between those two contemporary sort of messages?
Yeah, absolutely. It's a really good question, and it's actually been, I was surprised actually doing the research how there hasn't been this defensiveness, you know, that there hasn't been this sort of overwhelming desire for a return to fires, but there was an appreciation of the kind of warmth, comfort, joy that can come from the coal fire and how that's related to their own cultural heritage. It was actually quite surprising. Quite a few participants talked about, oh, well, we can't be doing that anymore, though, can we, with the environment? And wouldn't necessarily elaborate much more. I mean, wouldn't necessarily be able to. They might, you know, not be able to articulate that or have the knowledge, which is fair enough. And that's a whole different sort of question there. But there was an awareness of the positive impacts of moving away from what you know. And in a thermal comfort perspective, that came from people recognising that gas, they're much more comfortable, even though they really liked their coal fire. And in the current situation, people have recognised even, oh, everyone's getting log burners now, but aren't we not supposed to be doing that? You know, so these elements of this awareness are coming through. And even though we're in these coal mining communities, there wasn't this overt, you know, need to return or defensiveness necessarily. It was more a concern, like Carol in Maltby, who says they're not going to take that away from me, are they? Because there's a feeling of unpreparedness or a lack of control. And that was the same with Mary, who lived on the tenant farm. They, you know, being sad that they've stopped delivering house coal because it helped to get a fire going. It's that kind of enforced change that was more the issue, rather than having some deep-seated need to have coal itself. Does that make sense?
Yeah, no, that's interesting. I'm going to paraphrase two questions, taking them separately, and they're in the chat. One sort of carries on from the element that we're exploring here, I suppose. You've mentioned your second fieldwork area. Do you call it Stanford?
Yeah.
Is that a mining community?
No, so Stanford, sorry, I realised I rushed over that in the presentation accidentally. So Stanford is a semi-rural market town in the south of Lincolnshire. So I've been speaking to people who, that it's actually a medieval town, so the housing stock is dramatically different to, say, Maltby, Rotherham. The housing stock in Stanford, there's a lot of Georgian buildings, a lot under conservation, which is a massive issue. I've interviewed people in medieval buildings, which is pretty wild. It's got a lower, it's not got as many people on gas as the national average, although, you know, there still are. But the main reason we went for Stanford as well was to see what this contrast would be like to not go to another coal mining community. And it really has come through then, the kind of importance of place. There's not this allegiance to coal in any way that does come through in a kind of sentimental, social, cultural way from Rotherham. That's really absent from the Stanford case study so far. And we haven't had a chance to fully analyse those interviews yet. And we're going to be doing that over the coming months. But having done the interviews myself, that's my immediate reflections on that.
Okay.
Yeah, because it's in UK time.
Oh, sorry. Do you want to put yourself on? Yeah, you've done that right. Kathy, that was me rechanneling a question about the joyful experience of real fires in the south in southern England. So I think we got there through the finding out Stanford wasn't a coal community. So thank you for that. Then there was another question. How do you think the oral history can help transition? What are the 3 main lessons? Or not 2, it's got to be 3.
3 main lessons. It's probably a bit premature for me to answer that question, as we've still got another year left on the project.
Okay.
As I said, we do talk about early messaging, so please do go and have a look at that report. But ultimately, with the oral history, it's moving away from this purely technological approach and thinking about technology as, you know, the main messaging behind things. And through oral history, we're gaining a much deeper understanding of how people relate to their heating systems and fuel. And by more deeply understanding people, we can make more effective policy choices and communicate that more effectively as well. So the point of this really is by looking at people's past, we can better understand the present and much more deeply, and focus on that social and cultural elements of transition that haven't really been recognised before. But ultimately, it's people you're trying to make change, so we need to understand them better too.
Okay, thank you. Final question again. I'm going to paraphrase it because I can build on what you were saying about Stanford and the really old houses and their configuration. Thinking about modern houses that are being built, you know, the last 10, 20 years or so, which tend to be smaller. How do you think the work that you're doing in understanding the way that people live with fuel, live with heat, tells us about how people might be living with contemporary constructed houses and their fuels?
Okay, well, just reflecting on the kinds of people we've actually spoken to, we've spoken to people who are living in new build houses. You know, it's not just old houses there, just to clarify that point. And I was speaking to someone in Stanford recently, actually, who was a tenant farmer. They grew up in this massive 18th century farmhouse that had 9 bedrooms. And he talked about how he drew on these, the joyful elements of fire and having that kind of main source of heat and the kind of sense of care and the things that came out as well in Rotherham. But he actually now lives in a new build with solar panels, and he says, this is much more suited to me. So I think the lesson here is that the absolute diversity of experience and preference that we're seeing, it needs to be constantly considered. So I'm not going to try and make a grand statement about understanding people who live in new builds, but what I am saying is that we have interviewed people who live in new builds, and a lot of people reflect on their situation in a really positive light. Other people still look back and say, oh, I much preferred that. I'm not sure if that's helpful, but ultimately understanding the complexities of this issue can, you know, help us move forward. So
yeah, great, thanks, Kathy. Just for everyone in the audience's awareness, there's an anecdote been added to the chat by my colleague John, which I'm going to leave unread out. If anyone wants to read that and have a chuckle, they can do so. But thank you very much, Kathy. That was great.
thank you.
So as Kathy signs out, I'm now going to tee up the presentation from Becky Shaw, who is another member of the Just Heat team, and Becky will introduce herself when I launch her presentation.
Hi, I'm Becky Shaw, Professor in Fine Art Practice from Birmingham City University. Before that, about 9 months ago, I was a reader in fine art at Sheffield Hallam University. So it's really nice to be in a kind of Sheffield Hallam context again. Today I'm going to talk about keeping warm, being cool, exploring experiences of warmth through art practice. Apologies for sending a recording. I would have really liked to be there tonight, but I'm in transit and I couldn't rely on a decent connection. I'm going to look forward to hearing some of your presentations when I access the archive. So I'm going to talk about this project, which is called Looking Back to Move Forwards, a Social and Cultural History of Home Heating, Just Heat. So the PI is Professor Amy Ambrose, who is also from Sheffield Hallam University. I'm the co-I, and our research assistant is Kathy Davis, who is also here tonight, I believe. So I hope we don't give you exactly the same introduction. We are also working with Sally Shazad from University of Leeds and colleagues from Romania, Sweden and Finland. So Just Heat is what it says on the label. It's looking back to move forwards. We are gathering oral histories. They are our primary mode of data collection as a mode to think about the last energy transition and how our relationship to our home heating can be explored by reflecting on our experiences. And we want to do that because we want to support how our current necessary energy transition can be managed in more just ways, in that we note that energy, our home heating methods, is more than just economical or technical. Those are not the basis on which we make decisions only, but that heating is embroiled and entwined with our way of life, our relationships, our gender, and our identity. So it's important to look at those connections to help us make better transitions in the future. It's a social and cultural history. So those are the aspects we're particularly looking at. And the important word there is that there is a history and there is this fundamental relationship to oral histories all the way through our work. I am an artist, and in addition to gathering oral histories and coalescing a big team of social scientists, Just Heat also puts artists in the mix as a way of trying to capture some of the emotional intensity and social, cultural and political meaning that home heating has. So to do this, we've been working in these 4 locations, Maltby in Sheffield, outside Sheffield in the left, which is the UK site. The image there shows Maltby's one of the UK's last coal mines, closed in 2013. Next to it is a diagram of Sweden's very light, efficient and appealing in that diagram electrical energy provision. In the bottom left is Finland with its relationship to burning wood. And on the right is an image of Romania's district heating system from the Soviet era. So you can see already there are these different fuels which are so important in our study and forge such different. So one of the things we did was to place an artist in each of those 4 locations. So we have Henna Aho, a textiles artist and painter in Finland, Ram Krishna Ranjan, based in Sweden, who's a filmmaker, Denise Lebont, a photographer based in Romania, and I am the UK artist. So I'm going to talk mainly about the UK site and my work today, because we're not at the point where we can talk about the different things that the 4 artists have found out in their different locations. So I'm going to wish you to a rainy, grey day in Maltby, where we did a lot of. So we were gathering, we had 35 to 37, I think, oral histories gathered in Maltby. So how on earth does an artist process oral histories? Now, I generally make live works in the public realm that involve a degree of performance or action, but I really struggled to kind of work out how I might process the oral histories. So I began drawing them. I was not drawing them to make artworks, I was drawing them to understand them. I haven't put the oral histories here as I didn't want to distribute them in this form. But you'll see that this is a speeded up animation of me drawing my way through some of the oral histories. You have to do it fast. Some bits of the story enable you to draw really fast. Some bits of the story are weighty with lots and lots of detail and description. And so even the act of trying to draw them started to tell me which things the person was paying a lot of attention to in their story, or indeed what they were drawing the listener's attention to and what they were quickly whizzing past the viewer or listener's responses. So it also made me think a lot about how the movements that I was having to do with my pen carried something of the movement of doing tasks, you know, and something of the materiality of the objects I was drawing, which again made me think of the labour embedded in stories. These are two of the drawings. You can see the difference here of a very fast drawing and a much more worked on drawing. And this description of the intensity of the coal fire, all the family gathered round, everyone felt safe and secure, so no one could reach them. They were happy. There's a whole set of these really intense, happy, dark and light, secure stories around the coal fire. In contrast to the image at the bottom, which is the future, which is you know, lots of descriptions of the future, light, airy and fast and less laboursome. So there's a sort of oscillation between the weight of coal and its intense thermal joy versus the light and speed of the new technologies. One of the things we did in Just Heat was that we analysed the work together. Now, analysis is a strange concept for artists. We don't really recognise the bits when we're analysing, the bits when we're collecting data. It's all practice, it's all working with material. But we did this active analysis and I thematically arranged the drawings, if you like, breaking them down into elements, which is something that art of course does, and then rearranges them differently. And so on this page you can see some heavy, dark, coal drawings and some very light, gaseous stories of new technology, of gas and electric coming in the 1950s, and you can see lots of images of switches where you could turn things off and on. So there was a lot of talk of ease and lightness and elevation and it being marvelous. Alongside these tales of the enjoyment and effort of cleaning your grate, carrying the weight of coal, dirt that was always in the air, but they're not as simple as one good, one bad. It's a much more ambiguous, emotional, tangled story about how your life connects with these things. One of the things I started to do was I collected photographs. This was a photograph given to me by one of the oral histories that I did, was to simply start to cut away and play with images that people had given me. So I started where the fire, you know, what is the inside, the outside of the fire? Where does our room begin and end? Where does the person begin and end? And it made me think about how the fire was inseparable to our way of life. I then started to think about Christmas cards, to move away from my drawings, and I gathered a really extensive collection of Christmas cards, UK ones. These are actually prints of Christmas cards, and they were all Christmas cards of fireplaces, and I was stunned that given we are a country that has very, very little snow now, how many of them featured the coal fire or the log fire. and yet all our Christmas cards show snow and open fires, which we also don't have so much. It is a real emblem of Christmas and all its light and joy and coming together. So again, I started to think about, what does it mean to take away the fire? What do we see when the fire is gone? And started to make these strange holes. And to think about what is always the same in these images and what's different. Some of them are modern digital Christmas cards that you can buy online. They're very strange. Lots of them have relationships, granddads, nans. Away the fire, where does the fire begin and end? There's so many cats. What are the different what are the different visual languages that we use to communicate fire? What's a white fireplace? That one's a very strange one. We begin to travel through time, through the whole, in all these different places. Equally, I started to gather children's book illustrations of fire, and to bring those, in a way, bring them back together with the Christmas cards, and to think about how does the fire relate to the environment it finds itself in? How do fires relate to our lives? These are all images of fire from children's book illustrations. And each one enables us to think or feel something different about fire. And also to think about the visual and digital languages, cultural languages, if you like, through which we represent fire. So following that, we also, I'm still working on that work, still chewing through the right way to communicate some aspects of the oral histories. But to add to that problem, if you like, we've been thinking about how we might bring the artworks to interact with public conversations. So part of Just Heat was also always to take people's experiences, people's accounts of their heating transitions to energy stakeholders today, and to bring the social and cultural dimension and meaning of history to bear with decision makers. So we've been thinking about how we have conversations between communities and energy stakeholders, and what artworks could do in the middle of that, and also what our different countries, how to do that in different countries. So some of the things I've been playing with is, if you think of the animations and the drawings as sort of using my hand to activate the space, these are making stage sets where we might invite people to reimagine how they engage with the fire. So these are my daughter, who instantly wanted to put things on the mantelpiece, to recreate fire, to be the maker of fire. Lots of things about how you go about making a fire. I've made some paper ball, and I've also printed some of the drawings huge, so people can reenact certain types of situation and think about how you might have used to perform around the open fire and how you might do that now. Oh, notice my cat was in that before then. I've also been projecting the images onto 3D space, noting that when you project light, you get this fantastic split of light along the edge, and how that might recreate some of the effects of the flickering fire, but also help us think about time and how our distance to some of these images, how these images are still familiar and part of our lives, particularly through Christmas, but also how they have a legacy and stretch back, both in the idea of coal as an ancient fuel, but also in to do with our history and culture of fire use. The way the table stretches the light made me think about the time in our images. Equally, I've been thinking about how people might interact directly with drawings. This is my daughter in a very strange coat, but almost moving the drawings off the page and onto her body. So how we might invite people to wear or have drawings on their bodies and to play with them as part of the public conversations. And I'm going to move on from that one. And I've also been thinking about how people might be invited to make the fire again. So this is me trying to build this particular way of coal fire making that one of our oral histories told us about. And it's me trying to keep up with the drawing and, if you like, relearn how to make. It was a particular way of making a fire so you could stoke it later when you needed it. So, and this is quite a weighty, quite a full slide, but I just wanted to draw out a few points about why art making might be contributing to just heat. First of all, it kind of amplifies. It is by nature an act of attention, so it draws things out of our data in a very material way. Art processes unpack the elements of a story, break them down into ingredients, and then reconfigure space and time differently to let us think about it, detached from the standard historic narratives. Although it must be said that oral histories also do that. They are not straightforward linear narratives. They put your body back into the data. They, by their nature, involves hands, my hands, and performers. So it enables us to think about our bodily relationship with heating again. It also offers the potential to engage with people differently. Finally, a what of cool, which I didn't talk about very much, my apologies, because most of what is done here is about trying to reach the personal meaning of warmth. So it isn't cool. However, I wanted to end with a note about how artists work in that artists, they don't have clear stages of gathering, analysing and drawing conclusions. So it can be very hard to be in an interdisciplinary research project. Artists don't want to say what it means. They don't want to tell you what to think. They don't want to spell out evidence or meaning. And they don't also work very easily to research project timescales. Artists need a lot of staring into space and thinking, which can sit at odds with the productivity-driven momentum of a funded research project. So in that sense, that cool is a bit of not wanting to, artists unsettle some of the business as usual momentum of a research project, but I hope that they also bring a richness and some type of questioning to how we form conclusions and how we understand what our research means. Thank you.
Okay, so thank you to Becky for that, and I will look back through the recording when I get it to see whether it's too glitchy, and if it's too glitchy, I'll redo it in the edit just to give full prominence to what Becky kindly put together there. Becky, I think, shows how an artist can contribute towards the sort of the interrogation of data gathered by herself and others, and sort of that openness of literally cutting into and rearranging the elements of the data to see what patterns, what understandings can emerge from that. And I think that's a really interesting form of analysis, even though Becky doesn't like the word analysis. It is analysis. And I've told her it is analysis. And we've agreed to share that word in common. I have momentarily lost the chat function. So I just need to check to see whether there are any comments or questions I need to be aware of and reflecting on. Can't see anything, so I think we'll move straight into our final pair of presenters, Karam and Mahatis. So if you'd like to launch us into your presentation, please, gentlemen.
Sure. Thank you. Can you hear me?
Sure. Yes, please, Mahatis, if possible.
Yeah.
The first would like to say good evening to everyone. Thank you so much for joining the session. I also would like to thank Luke for organizing. I call this very interesting session with different kind of topics. And today's session will be, in fact, the presentation between me and my colleague Mahatis. So I'll just provide an introduction about myself, and Mahatis will do the same before I can co-launching the presentation. My name is Karam Al-Ubaidi. I'm a senior lecturer in sustainable and environmental architecture at Sheffield Hallam University. I'm an architectural engineer, technologist, educator, and international researcher in environmental technology and climate emergency practices in the built environment. My research area of focus is on building performance, architectural systems, energy efficiency, and specifically also looking at urban microclimate and digital architecture in terms of modeling and simulation. And today we'll see some kind of information and simulation data in the presentation slides. Specifically, I'm focusing on what we call designing with data. Mahatis, to you.
Yeah, thank you. I'm Dr. Mahatis Hussain. I'm a senior lecturer of environmental architecture and technology. So my research area usually revolve around the indoor-outdoor environment, but we usually focus on workspace environment, where I tend to focus on how human users perform or users react to the environment. So it's both quantitative and qualitative aspect of human perception, and how they have an impact on efficiency, work efficiency, or health and well-being kind of part I usually work on. And also Karam and work together. Many of the projects in this presentation, we're going to show a little bit of those part of it. Yes, thank you, Karam.
Thank you, Mahatis. So today's presentation, in fact, we have what we call perceiving the effect of climate change and urban heat island on the built environments. In fact, the presentation is from architectural perspective, and we are covering this topic on two different scales at what we call urban and building levels. And that's why you see both of us, in fact, we're providing this kind of slides, because we would like to demonstrate the importance of understanding the relationship between outdoor and indoor environments and how both of them, they affect generally on human comfort. I'm just checking, Mahatis, if you have control, or you will have.
Yeah, I approved it. Yeah.
Okay. So just a quick, overview of the contents, because we are sharing, this presentation. So the first part, I will look at what we call the urban microclimates. So look at the facts and statistics of climate change, and we support this one with case studies in the UK. And the second part, Mahatis, we will look at that kind of transitioning from the outdoor into the indoor environments and creating this kind of connection. Towards the end, we try to provide some kind of suggestion of solutions to mitigate the urban heat island and how to increase sustainability in built environments in general. So just I call it on the previous slides, yeah, sorry. So I think it's quite important to have an overview of what we call it, the history of global warming, and how that kind of history is changed, in fact, from 1880 until 2023, until today, in fact. I'm just showing this kind of, I call it changes in the global temperature from what we call industrial period until today. And data is clearly indicated that the global average temperature is now 1.2 Celsius warmer than what we called before during the pre-industrial, I call it era of that kind of like time. So there's a kind of like a very big jump, and there's in fact evidence to prove we are facing an issue with, I call it global warming. And the second slide here, we would like to zoom in more into the UK context. And we will try to also critically observe the impact on the heat on land and how that's kind of called the aspects of land surface temperature in a way demonstrating that kind of heat. So the figure, in fact, on the left side demonstrates the temperature, especially of land surface temperature, during one of the hottest called periods in time. And I've actually noticed Chloe also during the first presentation mentioned about that period in July in 2020. And when she mentioned that is actually the highest recorded temperature recorded during the time. And we could see really clearly that the temperature, especially in the south, I've called it of the UK and England, around London or Sheffield High, have recorded the temperature more than 40 Celsius. Similar situation, we could see it clearly on the, I call it the right figure, where we try to do this kind of a comparison between different type of years, especially from the 70s and during, I call it 20s and now. We see clearly that the temperature is rising, as increasing, and that's in fact reflected clearly on how cities perform, how buildings perform, and what kind of the future direction that we need to go and move towards this kind of an approach. This is slides, in fact, I just want to show some kind of interesting facts and figures here. I know this currently we are in June, and currently this June is more cooler than last June and last year, but this is a kind of like a data we found it from the Met Office to show that the temperature or mean temperature in May 2023 and May 2024. And you could see clearly that this May is more warmer, in fact, that May. Although that we have some kind of anomalies and instability in the temperature currently, and I called in this June, but we see clearly that there's some kind of increasing in the temperature that's happening generally in the UK. And that's also wanted to reflect more in detail by looking at different regions in the UK. And it's just a very simple, I call it a calculation and comparison between the annual mean temperature for the UK around, we call it the industrial period in around 1884 and 2022, the difference shows around 1.65 Celsius. So globally, we look at it on the first slide, we see around 1.2 generally is warmer than before. Now you can see it in the UK is around 1.65 warmer than during that kind of period in 1884. The similar situation is not happening only on the UK, but if you want to look at different regions, especially in England, Wales, Northern Ireland, and Scotland, you can see that the chart during that kind of period is showing clear there's an increase in the temperature. Although there are some kind of fluctuations happening, and that's kind of like normal within the temperature, but the trend is going up and higher. And even by looking at some statistics and data, I've called compared to 2020 and 1972 during the energy crisis, so clearly see that the annual mean temperature in England now almost around 10.93, but before was around 8.78. Similar situation with Northern Ireland. If you want to do this kind of call it a comparison within a call last 30 or 40 years, we see there's a kind of like a steady increase in, I call it annual mean temperature. This I called from the previous slides. We just wanted to create this kind of call it an overview about the importance of the topic that we are working on. And the aspects that we deal with is related to urban heat island. So urban heat island, always this kind of phenomena, you'll find it around our urban areas or dense urban areas, such as what we call city centers or the larger city, where the temperature behave in a way higher than like a rural area or like in a suburban area outside. And the reason that that kind of call it a phenomenon is related to the cover of the city itself. And urban heat islands tends to happen because many of cities replace, or we call it, they are land surface cover from, we call it a natural way into more dense and concentrated called materials that focusing on pavements, concrete, buildings, surfaces, that in fact these kind of materials, they tend to absorb heat. They tend to retain heat in the way inside the city. And that's what happened as a reaction in that kind of called absorption and retaining of the heat. The energy demand started to be higher. So we need more of cold energy for either cooling or heating certain actually locations. The air pollutions, there are also heat-related illnesses. In fact, I received some of different presentations before this one. They mentioned about this kind of aspects. And if we really wanted to understand the impact of urban heat island, we have to understand how they impacted on human comforts. Because as I mentioned at the beginning, we are dealing with, I call it architecture, and we're looking at it from that kind of a perspective. We need to understand how people behave inside the city, how the user, they will feel comfortable inside, I call the city, with that kind of, call it, current issue with the global warming. And one of the aspects we're really keen to look at it, and we develop it further, is by looking at outdoor thermal comforts. And again, I could see some kind of similarities with the first presentation when Chloe mentioned about how the person could feel and react to the heat in that kind of a way. So what we do, in fact, in architecture, we assess that kind of like a requirement of outdoor thermal comfort using different factors, objective factors, subjective factors. So we don't only just rely on air temperature in a way to say, oh, I don't feel comfortable, or this is an issue with urban heat islands. However, we tend to deal with different kinds of scenarios and factors such as radiation, humidity, wind, metabolic heat, clothing insulation, and also the subjective, either related to psychological aspects or even behavior, how we behave, in fact, inside, I call the building or inside the city, will also give this kind of like interpretation, translation of the meaning of outdoor thermal comfort. Linking all this kind of called information will be quite interesting to see based on statistic and data. And that's what I mentioned, we are designing with data, is to see what's kind of number of hours in the UK in different regions, like in London, Sheffield, Bristol, Glasgow. You just actually randomly took this kind of called location to show how many hours above 20 Celsius they could actually achieve on this kind of different regions. And logically, you can see that London achieves the highest one. So there are more than 260 hours. In fact, there are more than 20 Celsius that are recorded in London city center. It could be actually more, maybe because this is what we did. We were calculated or analyzed based on 10 years average. But interestingly, you can see that Glasgow is the lowest one as the green color because it's in the higher latitude. But when comparing Sheffield and Bristol, we notice that Sheffield is more warmer and has actually higher temperature compared to Bristol, even though all of that, both of them are actually in different latitudes. And Bristol should be more warmer as it's actually lower latitude compared to Sheffield in the higher latitude. But the location and the position of Sheffield in inland, compared to what we call it in Bristol, which is near to the sea, that all play an important role on getting that kind of, call it, impact within the city. Again, all these kind of things lead us to what we wanted to discuss about the case studies or the things that we found it in the UK. And this is a very interesting, I call it a map, and this map called surface temperature map represent the heat stress in London. And this is coming from a public data set. So we're looking at the public data set from the government in London, and clearly show that in different locations around London, you see that the temperature is quite warmer, and that we refer to them as a heat stress. So in different locations, especially looking at the red color, those are the area recorded around 39 to 40 degree as I call the surface temperature. And this is information that presented here. It's just, I call the summary of information between 2016 and 2020 as a summer months. And this, in fact, show that if you live in certain location, for example, within this kind of called the red spots or heat stress area, you could experience what we call heat. You could experience even using energy in a different way compare, I call to different locations. And that's what the impact of urban heat island showing here. We wanted also to show some kind of comparison from London to other higher latitudes. So for example, this is another, I call it data sets available publicly, is about Edinburgh and showing the land surface temperature in between 2013 and 2022. So it shows clearly that certain area in the city they experience heat stress, although that the temperature here is lower, in fact, compared to London. But this is again reflects on why different location in the city they experience that kind of a high level of heat stress. This could be related to many things, as I mentioned before. It could be about materiality, it could be about urban morphology, it could be about the urban, urban dense, how actually people living in that kind of area. It's all reflected again in that kind of a way. We just wanted to bring that called a very general picture. So we started first globally, then in the UK context, then we look at different regions. We also wanted to share some kind of called a case studies. So this kind of case studies, we wanted to, in fact, investigate some kind of UK urban design and planning system. So we look at certain kind of, we call it a national model design code. And we try to validate some kind of those kind of, call it a code, to see it in from environmental perspective. Are they really well prepared? Are they really considered those kind of, call it urban heat island scenarios and situation and heat stress? So one of the studies that we conducted and done, we look at the high streets. And when we look at the National Model Design Code in the high streets, we found that this code is clearly stated there's a specific width of the streets that should be provided, and I call it in the design. And this kind of call it give us an idea to say, how if we implemented that kind of code on the actual, I call it city centers in the UK, and looking at some kind of examples, what's going to happen? What's the actual scenario that we have it? And what happened if we change those kind of, call it a design code, or we change that, call it the high streets in certain cities to follow design codes? So what we've done, we compared our, I call it investigation and data to a specific kind of standards. So for example, we have one standard we call the physiological equivalent temperature, PET, and there's a universal thermal climate index, because we can't only rely on the what we call air temperature to say is actually warm or is in fact cool, but there's certain type of, I call those kind of classification of the values. They clearly stated on which range they will be warm and which range they will be cool, and how heat stress could be reflected. So one of the studies that we look at it, in fact, we compare two, I call it areas in Bristol city center and in Cardiff city center. So we took two streets in each, I call it, of these city centers, and we try to look at them environmentally by assessing what we call urban canyon. So what I mean by urban canyon is a kind of like an environment between two buildings. And we try to look at what we call aspect ratio, the height of the building, the width between the two buildings, especially in one street. What happened if we are actually modifying those kind of called aspect ratio? Also, how we could look at sky view factor, how we could see that the streets, how they will receive that kind of solar radiation or the sun directly. Again, that's kind of call it a value or the factor is very important in the analysis. So we apply this kind of call it to two factors in this kind of call it to two cities within 4 streets. We try to identify what we could do and how we could test, I call this kind of hypothesis. So what we've done based on the survey that we've in fact implemented those kind of call it urban areas, and we try to compare them to the original, I call it width. So some of the street, they were within 28 meter widths, some of the street 18, 25, 11. So we analyzed, in fact, the actual condition, and we did this kind of called modification to all of them follow exactly what the standard requested. And we only targeted the minimum requirement of the standards by looking at 15 meters as actually the width. So we adjusted all these kind of things. We've done everything based on what we call simulations. And we try to test what the kind of like impact would be on urban, I call it microclimate. And interestingly, this is just want to show some kind of call it an outputs. So the outputs that I call show on the left side is mostly about solar radiation, the impact of the solar. So in Cardiff, originally, all this kind of like a top, I call streets, they were quite wide, around 28 and 25. What happened, we tried to actually reduce the width of them to follow the standard with 15, I called meter. And interestingly, we noticed that the temperature, I will call temperature, the solar radiation dropped, which is in fact affected on the air temperature around that area. And here maybe just the legend is a quite smallish, you can see it clearly, but it's reflecting the colors, in fact, reflect that kind of called the language. When you see kind of like a red or dark red is represented as very hot, while it's come to the green or bluish color, it reflects actually more cooler kind of sense and temperature. So we've done this kind of things, what we call it in Cardiff. We've done similar situation in Bristol. We look also at the same time on the wind flow, because as I mentioned, not only temperature, so we have solar, we have also the wind, we have a humidity, all this kind of a factor is very important. And we place those kind of quality model in a specific, we call wind tunnel, using CFD, computational fluid dynamics, and we try to assess how the wind will flow, what the speed of the wind will be inside those kind of streets. And interestingly, from combining all this kind of called investigation, we generated some kind of, call it, outdoor thermal comfort data or measurement to see what's going to happen if I, for example, reduce the size of the street from 28 to 15. And what we noticed during 21st of June, because we're taking the first day of the summer and the highest, I call it, angle of the sun, the temperature has reduced by 0.7 Celsius. And what happened when we actually reduced from 25 meter to 15 meter? The temperature around June dropped around 2 Celsius. So we've noticed that, oh, there's some kind of cold achievements happening there. By reducing cold width, there's kind of cold improvement happening during the summer. However, we did also some kind of studies during the winter, and we tried to see what's happened if I reduce the street width. Is the winter will be better, or winter actually will drop? Certain cold streets, they drop significantly. So in the summertime, they were reasonably around 0.7, but around the December and winter, they dropped around 5 Celsius, lower than the original, I call it, measurement or data. The other scenarios also, some of them, they were stable. Some of them actually, they also change. What we found from this kind of investigation is not only following the size of the street, but there was another factors, such as we call the aspect ratio and the sky view factors. And we found that if there's kind of called inverse relationship happen between them, the temperature will drop in the winter. However, if they have the same relationship, they increase at the same time, they reduce at the same time, the temperature during winter will not be affected. Again, all this kind of things, we've done it and we measure it using simulation. And now we are in the progress of testing it empirically. And we're looking at the practicality of all our approach on investigation. But just give us a clear idea how we could assess the impact of urban heat island and how we could look at those kind of called technical solutions in a way of improving some kind of called actual urban context in the UK. Also, just want to share another project. This is maybe is not related directly to the UK context, but one of the projects I've worked before in a different, I call it, climate context, and what this is in fact in Malaysia, in the tropical climate. But I just wanted to mention that we've implemented the similar strategy and a similar approach where we were looking at the assessing the quality of outdoor spaces. And we targeted one of actually case study. It was a university campus for the students. And we wanted to see what kind of quality of outdoor condition would be in different locations. So we selected 6 places and we look at shaded, unshaded, partially shaded, and we did all this kind of empirical investigation. We did also, in fact, in simulation testing, looking at the mean radiant temperature and wind. And we ended up, in fact, with very interesting results to show which which kind of spaces they demonstrate a good quality and which spaces they demonstrate bad quality in terms of thermal comfort or thermal discomfort. I don't want to bother you with a lot of technicality, I call it, with the approach, but that's a kind of called a technical way or technical method. We could assess it and we look at how outdoor condition, in fact, could affect on human and users, and also at the same time, how they could affect on the buildings and the user inside in terms of understanding the relationship between outdoor condition and indoor conditions. And that's why I wanted actually to lead with that, call it, slides to my colleague Mahatis, where he wanted to reflect clearly on some of the case studies that we just presented in London or different locations, especially in Sheffield, how that outdoor affected, in fact, indoor conditions. So yes, Mahatis, so up to you to carry on with this.
Yeah. So sorry, I know that we're running out of time, but just to kind of show you the transition point between the indoor and outdoor temperature profile. So firstly, if we look at this picture, I'm sure you can recognize this. So it says now, you can see the heat map in the right-hand side. Where is this located? Not in the city center, cooler area compared to the city center. However, if you look at this picture slowly, And you can see the thermal image, which is showing the surface temperature. And if you spot the hot spots of the spaces, and all you can see that the hot spots are on the built surfaces rather than the greenery area. And you can spot that these are probably on the building. If I look at another picture, say same building in a different angle, but you can see that it's just careful that this picture has taken in the autumns or during March when I was doing the RIBA kind of a jury member. I was visiting those buildings, and you can see that the temperature is quite pretty high even in March because of the solar radiation. And if you look at again it's on the building surfaces. So of course the buildings are made of concrete and glasses, and also it's a residential buildings as well. And you can see that there's definitely outside you can clearly see that there's you can perceive the temperature anyway. Secondly, if you look at the another location, which is in London, which is also in September 2021, which is also during almost autumn time, and it is nearby the it's near to the city, but it's dockland areas, and you can see that this is the place where you have less trees and more built-up spaces. Even it's nearby water body. But you clearly see the picture of the thermal image is that, again, the hotspot actually on the building surfaces. So this is a view from the human scale. You probably see another picture of the same location, and you can clearly from the picture, without looking at thermal images, the hotspots are on the building surfaces, especially which are exposed to the sun. And if you look at the picture again, obviously you can see a better idea of how the outdoor environment, how built surfaces of a city exposed to the solar radiation, they actually have a lot of heat up generated by the material itself. But if you look at the same location of Sheffield and London from indoor, so you can see that you actually see as a human eye like that. But if you look at the surface temperature, you can clearly see that the higher temperatures near the glass surfaces where the solar radiation happening, but also the boundary of the glasses, it means the frame and other materials itself. So building material have a huge impact on how we experience the temperature and how buildings are impacted by the temperature, not only from solar radiation, but localized temperature. But as Chloe mentioned in the beginning, and Karam also mentioned that, but overall thermal environment, or which is when it comes to human beings, we talk about thermal discomfort or thermal comfort. It's also not necessarily the air temperature, air velocity, flow value, etc., but also the temperature, radiant temperature around you. So how you perceive the radiant temperature, how you're experiencing it. And we talk about this thermal discomfort from SIPSI guide in a workplaces. So for example, as an example, if it goes above 25 degrees Celsius in the summertime, it considered this as a not comfortable temperature, and it's usually the operative temperature. However, if you go beyond that, you're exposed to longer time for this, it becomes heat stress. And heat is not very good because it's a silent killer. If you continuously exposed to the heat stress in a workspace environment, or any kind of environment, you basically harming your health. Now, question is how to measure the thermal performance and its effect. And because my background is architecture, but we have a quantitative background to do scientific analysis and collect data. We collect data in various ways. First of all, we can collect data from data loggers, thermal images, IoT devices. We have building integrated BMS system, also weather stations that we can collect data, which is more objective data. However, it's very difficult to measure how humans perceive the heat. So we need to have some questionnaire survey in 1 to 5 scale, 1 to 7 scale to find out those perception. But also, as Karam showed before, we also can use simulation to predict computer-based AI technologies to predict the temperature or thermal environment. Just quickly give you a presentation which Karam and we are working on, workspace environment of the house, residential building and non-residential building in office spaces. This is a building that is located in Sheffield in the city center and office spaces. And it is going the temperature of summertime. And if you look at not considering the weekdays, the office hours has highlighted. You can see that in July in 2022, when one person mentioned the temperature go up to 40 degrees, you can clearly see in this temperature profile is that outdoor temperature, which is dotted line, goes up to 40 degrees, and you can clearly have a relationship, the outdoor temperature to indoor temperature, which also goes high up to 30 degrees, for example, or one case is 28 degrees. It means that with this workspace is constantly exposed to quite higher temperature. And if you're working in this office spaces, obviously, if there's no air condition, it means you're constantly struggling with the heat. And same, I'm going to give you all more detailed information on another project which I have published and which is located in London. It's institutional office spaces and educational spaces, which is we can see from here. It's also located quite a hot urban heat island areas. And the reason I'm showing these pictures because we collected data two different ways. One is the BMS data, another one is the data that is already we have data loggers. And here again, similar kind of scenario, you can see that the temperature, when its outdoor temperatures goes higher, as high as 35 degrees, indoor temperature also tremendously going higher than to 32 degrees. So, but interestingly, you can see there's a difference between orange color and green color. The reason behind the orange color is actual building information, building management system, which already have a sensor. All our buildings usually have sensors that collect data. But the bottom line is here, this data doesn't say true story because they're probably on the building wall, doesn't say how we actually experiencing in the actual workspace while working. So the bottom line is through this data, we can also see that how's the building performing, but you also need to know how users actually feel. So there is a very rigorous method called BUS questionnaire survey, BUS BUS, and that basically we actually in this project we had conduct a questionnaire survey about 83 office workers, and in addition to students, students have another 100 above 100. But you can see that here the temperature profile, which is here is in the summertime, clearly show they're unsatisfied more during overall summertime. But also you can see the relationship, the summertime and the health, because they also perceive health is an issue in these office spaces, but productivity also lower compared to other time. So it means that you can see that there's a clear relationship somehow with the heat exposed to hot environment, their health and productivity. So basically, because we're talking about how to perceive the effect of climate change or health, you can see that this is the overall real health risk for human. And of course, for climate change, we can expose to extreme weather condition that includes extremely hot day, one of the days. And you can see that there's a clear indication that can have extreme weather condition have injuries or heat stroke or many things, heat-related illness, which is clearly shows that how important it is to clearly firstly measure perceive the indoor-outdoor environment and architecturally, but also to understand how we can mitigate or reduce the health-related issue in addition to energy efficiency. So I'll take over the last slide for Karam to explain some solutions, some lights on that.
Thank you, Mahathis. So this will be actually, in fact, our last slide, but I just want to mention about some kind of solutions that could be provided to mitigate urban heat islands and how we could increase sustainability in built environments, especially if you want to look at that called city scale or wanted to look at from outdoor level. There are many things we could target, and there are key development areas, especially if talking about urban geometry. And in fact, like surface coverage or geometry of urban canyons, or looking at air movement and solar exposure. If we know those kind of how we could control, for example, like our surfaces, how we could control, as I mentioned before, sky view factor or the aspect ratio, the height, the width, all those kind of things, even the height of the trees and variation of height and street width. So all those kind of things could be one of the solutions to reduce, I call it urban heat islands. Looking at materiality and surfaces. So in terms of buildings, how the roof, in which kind of material the roof being constructed, and what kind of facade, the materiality of the facade would be. Those are all factors affected in a way of urban heat islands. Looking also at the materiality of our streets and open spaces, our pavements, vegetation in a way, what type of vegetation that we could bring. So if you are thinking about the green roofs, were to bring it in our buildings on top of the roof in the city, how many of them, where they should be actually located, all those kind of things, they could reduce the heat stress, I call it, in the city, to reduce urban heat island. Looking at the shading, the building foam itself and the building geometry has that kind of impact to provide a cooling aspect, similar to what we in fact showed in the previous slides. When we reduce the width of the streets, that the building itself drop shadows, or shade provided kind of like a shaded area. Again, the energy, in a way, how we're providing energy into our building, into our cities in terms of renewable energy, and also how we could control the energy consumption in building. So, for example, if I want to mention about a new development happening in Sheffield, there's a lot of new offices building now in Sheffield with a fully glazed, I call it, facades. During summertime, those kind of spaces, they will be impacted by heat, and you will need a lot of air conditioning system to cool the spaces. What happened to the heat that being trapped inside? All the air conditioning system, they will take it out, they will eject it or reject it outdoor. And that will increase on what we call it urban heat islands. So we have to know how to control our building in a way to reduce that, I call it, a level of urban heat island. And this is just a glimpse. There are many kind of technology and solutions available, but there are kind of call it different technical factors. We could look at it in a way to assess and also to provide solutions, I call it, here in the UK or even in different places in the Europe. So yeah, that's my, I call it, a final slides. I don't know how, sorry, I don't have the control. So click on the final slides. Yeah, thank you so much.
Thank you for listening.
Thank you both. That was great, and lots of science in there, which was a great way to sort of bring us back to where we started from, which was with the science perspective. Just to take you through by way of well, take you through a few of the questions in the chat. Someone's asked if you could make some suggestions about how at A level, so secondary school, senior secondary school level, students could do their own manageable level investigations of heat island effects. What kind of simplified investigation would you be recommending there? What equipment would they need? What scale of investigation do you think would be most manageable?
Can I add? Can I?
Yeah, sure, Mahatas, you can go first.
Yes. Actually, the project I shared, we did the similar kind of approach for university level, so I can relate that. So the easiest way to have a real-time data kind of visualizations, which can be done IoT devices. These days we have devices which you can put in the remotely somewhere in the desk, and you can see in the phone or on a screen. So in that, what you can do is that you can run some kind of small workshop like we run with the university students, where temperature is there, then you actually try to see what does you feel like and what does the temperature look like, then open the window and how you feel now. And you can clearly see, you can get the perception of students saying that, yeah, I'm feeling now a bit colder, but you actually can really see the temperature dropping as well. So in that way, students can understand better or scientifically, but in an engaging way, how how to perceive temperature and how you feel actually. So there's a relationship with your perception as a human being, also the data. So I guess this is a very good way of teaching students, because we've done the same project for university level and it worked really well.
Yeah, no, thanks for that. That actually fits into another of the questions that was in the chat, which was about how you investigate the subjective aspect, and you very neatly there linked the qualitative and the quantitative, you know, the body as a measuring device alongside scientific measuring devices, and inviting your participants to make a connection between the two in real time. That seems really really interesting, really interesting way to do it. A third question that's in the chat is about humidity as opposed to, I don't know what the technical expression is, but dry heat, you know, sheer heat. The proposition that's put in the chat is that the density of human bodies, I presume, and their sweat and what have you, has an effect upon humidity. To what extent have any of your studies been thinking about humidity as a factor separate from but running in parallel to raw heat, or whatever the expression is.
Yeah, Karan, do you want to add something?
Yeah, of course. Humidity is a very important factor. So similar like called the temperature, radiations, and the winds. In fact, the humidity will demonstrate that kind of called discomfort. And if you want to mention about from the subjective matter, so the behavior and the psychology about how we are actually perceiving humidity in a way is different from person to a person. It depends on how I call the person is physically fit or not, so they actually also perceive that kind of call it comfort in a different way. But they are one of the factors. So when we try to calculate the outdoor thermal comfort, so we include everything in a way. So we're looking at air temperature, radiation, humidity level, and the range of humidity that provide the comfort, plus the I call it wind speeds, and plus all the clothing and things. So they are one of very important factor. We cannot actually just take it separately by itself. What we need to include it as one of the elements of evaluation and investigation. But this will be quite interesting when we're comparing coastal cities and cities like in called mainland, like for example in Sheffield or other cities maybe near to the coast. So of course the humidity level in summer will be quite different, and that will call how they perceive it in that kind of a way. So it could be maybe they perceive that discomfort in that kind of call it an area higher than the others, but again could be the factor of the wind. There will be better in a way of ventilating the cities, better than what happening in the different cities inland like in Sheffield. So yes, all of them, they be connected together. We cannot actually just look at it as in a separate, I call it a way, yeah. But I just want to add something to the question before was about how to teach a kind of called A-level geography coursework, and Matt has provided very interesting, I call point. But if I really want to teach it, I think using the power of Google Earth, because Google Earth really provide a lot of information. I mean, in the way for any kind of student to really understand the density of the urban area, the materiality that available there, where are there actually the parks area, where there are the green roof, where there are the places where they have actually a concrete or non-concrete. So all these kind of things give them that kind of understanding to know, oh, this could be actually a high level of, I call it a density, and this could be a possibility of high temperature there. Let's go and utilize all those kind of tools and measure it there. While area near to the park has like maybe a less number of, I call it urban dense, and that would be quite interesting to say, I'll compare it. So you could compare that urban heat island into different kind of contexts just by observing Google Earth and doing some kind of call it physical testing and physical measurements. So again, all this be connected. And I think now with the idea of IoT, Internet of Things, using all this kind of sensors, smartphone in a way, they provide a lot of very quick information. So we could measure light, we could measure sound, we could measure a lot of things in a way with our smartphone. So that's to provide very interesting, yeah, I call learning experience.
Just to complement the things about humidity. Humidity is super important because that's why, I mentioned operative temperature in indoor environment, because it's very complex. Operative temperature is a very good way of measuring the thermal comfort, because operative temperature have a massive equation that combines the effect of temperature, humidity, radiant temperature, air velocity, etc. So operative temperature kind of tells the whole story. And obviously, when people are number of people is higher there through their respiration, but also because if it's rain in outdoor spaces, humidity tend to go higher, and that have a massive impact on not only human thermal comfort, that have impact on other parameters like acoustic, pollution. Higher humidity means less pollution. Higher humidity means less noise pollution. But interesting, the parameters are related. So yes, obviously humidity is one of the important aspects in addition to heat.
Thank you very much, both. So we have a few minutes left for any closing comments, observations, whether from a panel member or anyone who wants to raise a comment in the chat. I'll just pause for a few moments. Can't see anyone particularly. I know you've had a lot to take in this evening, a lot of very rich content. Thank you one and all for your presentations. And we've ranged across some global science, some indoor science, some past, present and future cultural factors, and we've woven them all together. And we've certainly taken the full measure of heat and its existence amongst us, and inescapability perhaps. is the word. Is the word. So thank you for taking us in all those different directions. I'm not going to spin this out longer than these closing remarks. Kathy sent me a heart. That's very kind of you, Kathy. Right. Anyway, on that score, thank you very much, everybody. At some point next week, I'll have the recording ready to upload, and we'll send an email message around just to let people know that the recording is then available. Just thank you all for your participation and insights. Thank you, and enjoy the rest of your evening. Cheerio. Bye-bye.
Thanks, everyone.
Thank you.
Thank you.
Bye-bye.